Hello everyone, welcome back to our mathematics recordings. Let's talk about the concept of sectors, arcs, segments, we can even include the concept of chords. Now, if you have a circle, this is the center of the circle. Now, let's start with the concept of what we call a chord. A chord is a straight line that touches any 2 points on the circumference of the circle. So here, if we have a line this way, the line will basically be called a chord, provided it touches 2 points on the circumference. Now that means that the chord can divide the circle into 2 parts. So a chord divides circle into 2 parts. We have the smaller part and a bigger part. So the smaller part is minor while the bigger part is major. So fundamentally we can say the chord divides the circle into a major segment and a minor segment. So the chord divides the circle into major segment and minor segment. So the smaller part is called the minor segment. Let us start with how can we find length of a chord itself? How can we find length of a chord itself? How do we find length of a chord? If this is the center of the circle, let's say O, and this is a chord, let's say AB is a chord that we want to find the length. Now distance from the center of the circle to any point on the circumference is called radius. So here, radius, this is also radius. Now, we have angle subtended at the center of the circle, that's theta. Now we have a bisector of the angle. A bisector of the angle, that's a bisector of the angle is theta over 2. So if you have angle theta at the middle, if you divide the angle into 2, so this theta, this place will be theta over 2. And this angle 90. Now let's call this point x. Let's say m to b equals to x. mb equals to x. Let's use the concept of SOHCAHTOA. We have information about the opposite. facing the given angle theta over 2. And we also have hypotenuse, which is the radius. So sine of theta over 2 is opposite over hypotenuse. Sine of theta over 2, the opposite is x, the hypotenuse is r. If we decide to cross multiply at that point, on cross multiplication, s will be equal to r times sine of theta over 2. Now, the length of the chord, basically, now, if MB is x, MA will also be x because M is a bisector of AB. So length of chord will be equal to 2x. Hence, the length of the chord will be equal to 2. X is r sine theta over 2. R sine theta over 2. So length of chord is 2r sine theta over 2. Length of chord is 2r sine theta over 2, where theta is the angle subtended at the center. Length of chord 2r sine theta over 2, where theta is the angle subtended at the center. So a typical situation like this where we have the center of the circle and angle theta. So the typical length of chord described as A to B. The length of chord is 2r. 2r sine theta over 2. Okay, so we have that. That's about length of chord. Let's talk about the length of an arc. Let's talk about the length of an arc. An arc is a path from the total length around the circle. So the arc is a part of the total length around the circle. Remember, the total length around the circle is called the circumference. The total length around the circle, don't forget, that's called the circumference. So if this is the total length around the circle, a part from the total length around the circle, a part of it is called the arc. So typical part of it, let's say from here to here. So this is called the arc. You can even decide to call it arc AB. Arc AB. So let's find the length of an arc. Now, if the arc make an angle theta at the center of the circle, what will be the length of an arc? Now, the most important thing we need to understand is that the length of an arc is a fraction from the total length of the circle. The length of the arc is a fraction of the total length of the circle. So now let's establish a simple proportion to analyze that. Now, if an arc subtends angle theta at the center of the circle, now remember that the total angle round the circle is 360 degrees. This will be equals to, so we are trying to establish a proportion of angle to length. The angle by the arc is theta. The total angle round the circle is 360 degrees. This will be equal to the length of the arc divided by total length round the circle is 2 pi r. On cross multiplication, we have length of arc times 360 degrees equals to theta times 2 pi r. Now we can say the length of arc on dividing through by 360 is theta divided by 360 degrees times 2 pi r. So this is the formula that we use to find the length of arc, theta over 360 degrees times 2 pi r. The angle theta is measured in degrees. Now take note that theta is the angle that the arc subtends at the center of the circle. The angle that the arc subtends at the center of the circle is theta. So if we have the center of the circle at this point, let's even assume that the length of arc we are talking about is AB. So the angle theta subtended at the center, let's say O is the center of the circle, so length of arc AB can be obtained. Now, one very important thing we need to take note is that if we decide to call this point P, basically there are two arcs in the circle, the bigger arc and the smaller arc. The smaller arc is AB and we have used as a point of reference, and the length of that arc AB, which is the smaller one, is angle of that arc, angle facing the arc directly, divided by 360 degrees times 2 pi r. Since we said length of arc is a fraction from the total length of the circle. Now, the length of arc AB, since AB is the smaller arc, AB can also be called the minor arc. So the length of arc we have fundamentally explained is length of minor arc. Now there's also another arc which is APB. APB APB is a bigger arc. So we can establish a formula for length of arc APB. Now, but we need to use the concept of sum of angles at a point. Now, because to determine length of arc, we have to consider the angle that faces that arc. So we need this angle here that faces the arc APB direct. Now, if the angle here is theta, then the angle that faces it will be 360 minus theta because both angles act at a point. Okay. So length of arc APB, because APB is a longer arc, so we call APB the major arc. So length of arc APB is major arc. And we can use the formula 360 minus theta. Since we have decided to call the angle facing down theta, so the upper one there is 360 minus theta divided by 360. Length of arc is the angle. So this is like angle. 360 minus theta is the angle over 360 times 2 pi r. Now another thing we need to understand is length of arc APB, which is major arc, could just be the circumference of the circle minus length of minor arc AB. And circumference of the circle is 2 pi r. That could just be 2 pi r minus length of minor arc AB. Now, one more concept about length of minor arc, or the length of arc we have explained. There's a relationship between angle at the center of a circle and angle at circumference. Angle at center is always equal to 2 times angle at circumference from circle geometry. Now we can be asked to find the length of an arc of a circle that subtends a particular angle. Now this time around, the question becomes twisted and it says subtends a particular angle not at the center again, but at the circumference. Find the length of an arc of a circle that subtends, let's say, angle 30 degrees at the circumference. Then we don't make use of angle at circumference to find length of arc. We need the angle at center. So angle at center in the same direction is twice that of angle at circumference. So angle at center that will be used to be 60 degrees. So take note of that. In solving length of arc, we make use of angle at the center. And we have been able to establish a connection or recall a connection from circle geometry that angle at center is 2 times angle at circumference. That's the concept of length of arc. So we talked about chords, length of a chord, 2r sin theta over 2. We've talked about arcs. Let's talk about sectors. Sectors. A sector of a circle is usually made up of 2 radii alongside with the arc. So sector is usually bounded with radius, radius, arc. It is bounded by So the idea of sector of a circle is a straightforward concept. If you have a circle with center, we have radius, and we have a particular arc. Now, this region is called a sector. Now, there are 2 parts to the sector. The smaller sector, we call it the minor sector, and the bigger part of the sector, which we call the major sector. Okay, let's talk about the area of sector. The area of sector is a part from the total area of the circle. That's just the basic idea. Okay. So area of sector is a part from the total area of the circle. So what do we have from here? We have so let's say this is sector. The sector subtends angle theta at the center. The sector subtends angle theta at the center of the circle. So we want to find the area of this sector. So this is what we use as the reference. We can establish a proportion of area, of angle to area. So the angle sector subtends is theta. Total angle in the circle 360 degree. Area of sector, that's what we want to establish a formula for, divided by total area of circle pi r square. Let's take that again. Angle of sector, area of sector. Total angle in circle, total area in circle. So area of sector, we can cross multiply. Area of sector times 360 degrees equals to theta times pi r square. So area of sector is theta over 360 on dividing both sides by 360 degree times pi r square. So that's area of sector. Angle of that sector, that's what we mean by theta. Theta means angle of that sector. At the center. So the most important thing is to be able to get the angle of that sector at the center. So even if we are talking about the major sector, let's just obtain the angle of the sector at the center. Then divide it by total angle in the circle times pi r square. Since area of sector is a part or a fraction from the total area of the circle. Let's talk about segments. Segment. So here is the center of the circle, and we have a chord. So this part, let's call it the segment. So the segment is the region in the circle that is bounded with the chord and coupled with an arc. So we have the chord coupled with this arc, then you have a segment. Basically, the chord divides the circle into two segments, minor segment and major segment. Now let us have the radius of the circle. So here we have the radius of the circle. Radius of the circle, we have theta. Now, area of triangle, area of triangle plus area of segment, basically is a minor segment, equals to total area of the entire shape. The entire shape is a sector. So let's dissect that. So area of triangle is half the length here, r, times the other length, r. We have explained that in our mensuration, times mensuration topic 1, times sine of angle between them. That's sine theta. Sine theta. Plus, we're interested in finding the area of the segment. This will now be equal to area of sector. Area of sector is fraction from the total area of circle. That's theta over 360 times pi r square. So area of segment or area of shaded segment, as the case may be, is area of sector. That's theta over 360 times pi r square minus area of triangle. Minus area of triangle, which is half r squared sine theta. So this is what we have. So thank you for listening. In my next video, we'll look at questions from segments. We'll look at questions from segments, sectors, arcs, and chord. Bye.